Alright, you guys, so this will be the lecture video for psychological research. And psychological research basically is the uh, scientific study of behavior and mental processes. Behavior is anything that we can see with our eyes, a organism do, and mental processes is anything inside of us, you know, how we think, how we feel, etc., everything internal. But of course, our behavior and mental processes are linked together. So it's a question of how do we process things on both levels, and how do the two different levels interact with each other. The scientific study um, of these things can be looked at with overt and covert behavior. So overt is things that we can see. Covert behavior is things that we can measure and reflect of our behavior, of our internal processes. For example, when we get stressed, our heart rate changes. Different stress hormones can be measured in our saliva, our blood, etc. But basically, this is how we approach things so that we can attempt to put a description to our behavior, our mental processes, how we can predict. Because, for example, with like psychological disorders, we want to be able to diagnose people who may have something like, autism, ADHD, uh, Alzheimer's, etc. Um, so we can tell if somebody is going to be having some sort of issue, and explain, why is it that that happens? Why is it that somebody can be more prone for something like depression? Um, why is someone more prone for something like anxiety, etc.? So a good scientist um, has these different qualities as they are searching for information. Be curious, but you are also skeptical, meaning you don't take things at face value. You don't take things based off of opinion. You need evidence. You need data to feel like it's worth believing some sort of claim. Things need to be open-minded. The scientist needs to, because you may not, as scientists, we do have our own personal biases and hopes, but the thing is that we need to make sure that we listen to any new information that could potentially help move the field forward. But the thing is, mainly, is that it's empirically based, meaning that any sort of theory that is developed is based off of what the data shows us. So how do we do research? This slide here, you guys, will be good for you to come back to, because this breaks down the scientific method, and I'll talk about all these individual steps in detail. But this is a good slide to come back to when uh, you want to review and make sure that you have an understanding of each of the 4 steps. But the first step is basically asking, coming up with a good question, identifying the question, etc. So step 1, you can become interested off of something that you saw in previous work. It can be an idea that you have yourself, and you just want to know. The second step then is you uh, start to put your ideas into um, both a theory and into a hypothesis. And a theory is something that gives explanation and can lead to prediction of your phenomena of interest, and there are examples later in the slides. The hypothesis then is your testable prediction of what you think will happen if you execute a study. So let's say that there is, you have a theory, an explanation that people who experience depression, they are, people who have depression are also dealing with low self-esteem. Low self-esteem feeds into depression, and that, the two of them are related. So to test this then in your hypothesis, you then can say that for a formal way of doing a study, gathering data, you can say that predict if you score high on the Beck depression inventory. So if you have a high level of depression, you're then going to also have low scores on the Rosenberg self-esteem scale, which is saying that if you score high on depression, then you are predicted to have a low score on self-esteem. Another example, people who have antisocial personality disorder, that is kind of like a sociopath. People who have this disorder, they have a low empathy capabilities, meaning they don't feel for the other person or other people. So if that is your theory, you think that people who are sociopaths, part of the reason why they are a sociopath is they aren't able to process emotion for how, people around them are being affected. Then if you are diagnosed with antisocial personality disorder, then you will show lower levels of, overt, covert, psychological and physiological arousal. For example, like if you or I were shown videos or photos of kids who have been hurt really bad, that would lead us to feeling, uncomfortable. Well, people who have antisocial personality, they will not, because they don't feel bad for the other person. But again, the idea is that you have come up with a way to test your hypothesis, gives you a way to test for what is going on in the theory that you think is, the explanation of things. Here's just another example. Let you guys look through that. So after you have your hypothesis, then you go off and just kind of conduct your research. You need to figure out a way to operationalize it, figure out what the research method is that you want to use, collect your data, analyze it, and hopefully publish it. Now, when you publish it, the final step, you go through what is known as the peer review process. And the peer review process is basically when you think you have some interesting work done, you need to submit your work so that other people who are experts in the field can look it over and make sure that what you have done is properly analyzed, the experimental design is a good idea, um, and all those sorts of things. But basically, it's just the way that we double check to make sure work is good before it is published so that people in the public can see it. Now, in step 3, there was this mention of operalization, and basically what that means is how do you turn the thing you're studying, like say you're studying depression. Well, what does depression actually look like? Meaning, you need to find a way to define how does the thing you're looking at, how does it operate? How does it work? What does it, physically look like? So for example, like how we all know what it means, to be smart or silly, like when we say that in conversation. And that is what a construct is. A construct is the intangible quality, depression, happiness, anxiety, etc. But what does it actually look like? So, for example, silliness, you can operationally define it as how many times does a person actually laugh? How many times does a person attempt to make a joke? These are the behaviors of how a construct like silliness, how it operates, the operational definition, how it works. So these are just some examples for you. Uh, I'll let you guys look through these. And so with different types of research, there are different qualitative and quantitative methods, because the whole point of science is to conduct research. So qualitative and quantitative, these are the different things, and I'll go through these each briefly for you. So naturalistic observation, this is when you are just sitting back and watching the world unfold. You are just seeing how things are done, without you intervening in any sort of way. That is Jane Goodall. She is someone who's very well known for observing chimpanzees in their natural habitat, because she's interested in how do we primates and humans, how do we go about creating a sense of culture. She just observes and see how things unfold at their own pace, people watching. The Hawthorne effect, though, speaks to the idea that as soon as we know that we're being watched, that can change how we act, meaning that when you do naturalistic observation, you need to make sure that you do the appropriate job to make sure that nobody knows that you are actually looking or watching. Clinical method can be a mixture of naturalistic observation and an experiment where you are maybe you're being tested when you are receiving some sort of therapy or help, and they're trying to see its effectiveness. A case study is something where you follow a select individual or a small group of people very intensely. It can be for a short period, it can be for a long period. This girl Jeannie here, she is an example of so Jeannie has a sad story where for the first 13 years of her life, she was locked up. Her parents just kind of tied her to a chair and locked her in a closet for the first roughly 13 years of her life. Jeannie helps us understand the developmental process that we go through during those first years of our life. Because when Jeannie was found and saved, she was basically operating at like a toddler preschool um, level of abilities, physically, mentally, cognitively, etc. Um, uh, but yeah, she shows that if we're deprived of that normal development, what can happen to us. There aren't many people like Jeannie, but what we learn from her attempts to explain to everyone like what would happen to us if we went through what Jeannie went through, kind of a thing. So other methods, surveys, archival, meta-analysis, mentioned these. Archival is basically you are just looking back on information that already exists. For example, here in the U.S., there is a interest in people moving from state to state, and why that might be. Job loss, higher taxes, etc., in living. But you can look up information that already exists, but the information that already exists may not be enough sometimes. Surveys are basically where you are. So, like, let's say, for example, I'm curious about the study habits of college students taking intro to psychology. It's not feasible that I am going to be able to ask every single student in the world who's taking psychology, but I can send a survey out to a subset population that best represents the entire population. So maybe I'll only ask like 200 or 300 students, but based on the responses from those 200 to 300, it would be a fair, close, hopefully a close representation of everyone. With random sampling, though, you need to with surveys, though, you need to do what is known as random sampling. Random sampling speaks to the idea that you are giving everyone an equal chance to be a part of your survey. You're not picking or choosing one over the other because you don't want to appear to be biased. Meta-analyses. Meta-analyses is kind of like, so the field that I studied in for a while was the neurobiology of addiction. A friend of mine wrote a meta-analysis where basically he just read and reviewed roughly about 120 different articles, 120 different studies. And he then just kind of summarized in one paper what the general trend of the data is like from everyone who, from those 120 studies. So it gives you, a proper or a big summary. Correlational studies. Correlational studies basically is where you are measuring two different variables and seeing if they, how does the data move as one variable increases or decreases, what happens to the other variable. A correlation can either be positive, that's that +1, or it can be negative, the minus one, and I'll show you what I mean by that. So a positive correlation is basically as one piece of data as our age increases, our shoe size tends to increase as well. So positive correlation is as one variable increases, so does the other. Negative correlation then is as one variable increases, the other one goes down. And you can also have zero correlation, where the date, like if you were to draw a best fit line, like in these, see the line that cuts through the data to best represent the trend. Well, with a data set like this, there's nothing really going on. There's no real relationship going. And this is looking at, how big is your big toe compared to how well do you do on the SAT? There's not going to be any real data there, any real meaningful. So of the following correlations, what is the strongest? Now, that negative sign there tells you that this is a negative correlation. The size of the number is what tells you the strength. So a 0, closer to 0, means weakest. Correlation cannot exceed the absolute value of 1. So even if this negative sign wasn't here, that would just mean, if the negative sign wasn't there, then that would mean that it would have been a positive correlation. But the 0.98 is the strongest. The negative sign just tells you it's a negative correlation. So 0.9 in absolute value is still smaller than 0.98. So here are some examples of correlations. But correlation does not mean causation. What do I mean by that? So correlation does not mean that the two variables are necessarily causing and affecting the other one. So for example, there is, this idea that your household income based off of years of education. Well, we don't know necessarily which one is affecting the other one. Is it your years of education influence your household income? Or is it that your family has a certain household income that allows you to go and get a certain education? So which one comes first necessarily? And it's a tough question to answer. Also, there can be the problem in correlations where the third variable issue, and the ice cream drowning in the river, for example. So, okay, what I mean by this is, so when I was an undergrad, there was data from the town that my school was in that showed that as ice cream sales went up, so too were the number of times that kids were falling through the ice, and potential drownings. So people in the town became hysteric and they tried to shut down the different ice cream stores. But basically what my professor then said is, this is a good example of the third variable problem, because in Minnesota there is winters, and the ice cream sales going up is not causing the drowning. Around April, May, it's getting warmer again, and because of warmer weather, people are more likely to want to buy ice cream, and also because of warmer weather, the ice is getting thinner and people are falling through. So the third variable is what is really causing it, even though if you just look at the data, this quote unquote relationship exists, but that does not mean that that is the relationship that is causing the data to look the way that it does. Okay, so the last thing then is with experimental research. And experimental research is where we can establish a cause and effect relationship because you are doing what is known as a experimental manipulation, where you are changing one variable, um, and I'll explain this through. So basically, you have what is known as a control group and a experimental group. And again, there is random assignment to being in either the control group or the experimental group, to avoid any sort of bias. So what happens in a experiment then is you are either in the experimental or the control group, and what happens then, I'm gonna find a better one. Let's see. Okay, here's probably the best one. So let's say you are developing a new antidepressant medication, and you want to see if it works. So you you take people who are dealing with depression and you put them either into the experimental group where they are receiving the new drug. The control group then is they are receiving the placebo. A placebo is a fake pill, a sugar pill. It's not the actual medication. So, as you can probably see, then the people who are in the either group, they don't know what they are receiving. They just know that they are a part of a study, but they don't necessarily know if they are receiving the new drug or if they are receiving the placebo, um, because the placebo effect is the idea that, just thinking you're getting something can actually make you feel better. But basically, then, so um, because of this manipulation, where you are manipulating if somebody gets the drug or if they get the placebo, you can then compare how and evaluate how are the people doing. Let's say after 3 weeks of taking the drug and 3 weeks of the control different group taking the placebo, does the group that just took the drug, how is their depression doing compared to how is the group that just took the placebo? And you're hoping that the group that took the drug, they are doing better. And because of that manipulation, you can say that this drug caused a significant drop in people's depression level. And so you can say that there is something interesting going on in the data. So when you analyze your data, you're hoping for what is known as a significant outcome so that you can confirm or deny your hypothesis. And another key thing about science, the scientific method, is replication. You want to be able to replicate any work that someone has ever done anywhere at any time. And that is due to a good methods in your experimental research, meaning you broke it down very well as far as how you did your work, so that if I did my work here in Minnesota, you over there in China could pick up my research paper, see my methods, see how I did my work, and then if you followed my work, my methods step by step, you should get the same results. Thereby meaning you replicated the results. I mentioned bias, and there's something tricky to avoid. Um, you, the experimenter has their bias. Participants, they may act differently, the Hawthorne effect, sort of thing. So just how to avoid it. To avoid it, we talked about random assignment, people getting an equal chance of being put in the experimental group or the control group, a blind experiment, and a double blind experiment. So a blind experiment is where I kind of mentioned earlier that when a participant comes into your study, like with the antidepressant, they may or may not know, they shouldn't know if they are getting the new drug or if they are getting the placebo. Single blind means that the experimenter or the subject, they don't know what they're getting. Double blind then means that the subjects don't know what they're getting, and then the research aid person who is handing out the drugs, they don't know then what they are giving the subjects. Somebody knows, who is getting what. But as far as the person who is handing out the drugs and then recording the data in double blind, they don't know what they are handing out, because if you, the experimenter, knew what you were handing someone, it might influence your interpretation of their behavior. So then somebody, your superior then knows what you are handing out, but your superior is not the one who is collecting data. They just know what is going on as far as the administration, but they aren't doing the research. The ethics of research. You should always feel safe. You should always be able to not do the experiment if you don't want to. Never coerced. And we'll get into why, with social psych, why these things are in place. We do use animals in psychological research. We can learn a lot about their behavior. Well, for example, like I worked with rats when I did my research, and basically, a rat's anatomy, even though their brains aren't as big, but their anatomy is basically the same design as ours. So, we were able to do a lot of work with them, because, if you want to do like a long-term study with humans, you don't maybe have the luxury of waiting 20-40 years, but a mouse or a rat, they go through the same aging process as we do, but they do it in a shorter amount of time. Okay, so that is the scientific method, you guys. Your assignment will, you should see it, and basically you are just going to be creating your own research idea. If you could do something, what would you expect to find, that sort of a thing. And then you're going to see if anyone's done any work related to it. So yeah, let me know if you have any questions, and take care, you guys. Bye.